Hello again and welcome. I got a few more notes for you here today, so have your notebooks out and let's get to it. So we got an ion, which is an atom that has a charge due to the loss or gain of one or more electrons. So previously we talked about how electrons was always the same as protons. Now it's not. So now it can be a different number. Cation is a positively charged ion, and an anion is a negatively charged ion. As I teach this to you, I always try to come up with like little cutesy things to show you. So an easy way to remember that a cation is the positive one is that there's a little plus sign right in the middle there in terms of the T. You could also say that a cation has the word cat in it, and cats are positive. Yeah. All right. I know. Makes me die inside as well. Anion. The way that people remember that sometimes anion is the negatively charged ion is that it has two ends, and for negative, sometimes that helps people. I also had someone come up with once that anion kind of looks like the word onion. And onions make them cry, and crying is a negative emotion. So, hey, whatever works for you, as long as it works. Remember that cation is the positive one, and anion is the negative part. Cation is the positive ion, anion is a negative ion. Moving on. Electrons can be placed into shells. The first shell can hold up to 2 electrons. Those are those orbitals that we talked about before when you were doing those Bohr diagrams, those circles around the nucleus of the atom. The next 2 shells can hold up to 8 electrons, and the next 2 shells after that can hold 18 electrons. The electrons in the outermost shell are known as valence electrons, and these electrons are the ones that are responsible for bonding. So sodium has a total of 11 total electrons. 2 are in the first shell, 8 are in the next shell, and 1 is in the last shell. That means it has 1 valence electron because there's only 1 electron in the last shell. So if I was to draw that for you real quick, let's say that that's the nucleus. It's a lot bigger than that, and there's more going on, but we don't care, so we're not going to draw that. The first shell holds 2 electrons. We're going to put them there. The next one can hold up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the one after that can hold another electron. If we count them up, that's going to add up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one at the very end, that's the valence electron. That's the one that does the bonding. All right, let's move on to what we're looking at today. We got our opener. Here it is. Pause the video, try to answer it, and we will talk about the answer in just a minute. Okay, so hopefully you paused it. Let's talk about what the answer is. It says a hydrogen atom has 2 electrons. What's the charge? All right, find hydrogen on the periodic table. I can't necessarily flip there because then I won't be able to write on this anymore, but it is in the top left corner. And you should see that it has an atomic number 1, which means it has 1 proton. So I'm going to put a +1 charge right there. And I'm 1 proton. Protons are positive. That's why the +1 is there. And it has 2 electrons in this question. So 2 negative charges. A positive and a negative will cancel each other out. So these will cancel, and I will be left with a charge overall of -1. Let's do the next problem. Find boron on your periodic table. It's the 5th element. So find atomic number 5, and it'll be there. Because it's the 5th element, it has 5 positive protons. So let's put in those 5 positive protons. 1, 2, 3, 4, 5. In this problem, it says it has 8 electrons. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. Remember that the positive and the negative are going to cancel out. So these cancel, 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 and what's left is going to be the charge. In this case, 3 negative charges or a charge of -3. Because it's negative, it's going to be an anion. Next up, we got fluorine. Fluorine has an atomic number of 9. It's on the top right side of your periodic table. Go ahead and find it there. And you're going to see that it has 9 total positive charges. 4, 5, 6, 7, 8, 9. In this problem, it also says that it has 9 electrons. So let's put in the 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Electrons are negative. That's why there's a negative symbol. Whenever a positive and a negative line up, they cancel. So let's cancel them out. 1, 2, and these are canceled and canceled and canceled and canceled and canceled and canceled and canceled. And the question is, what's the charge? Well, everything canceled. So there is no charge. It's a charge of 0. Is it a cation or anion? It's neither. It's just what's called an atom because there is no charge. Okay? Everything canceled out, and that's totally fine. Everything can cancel out. All right. Next, let's look at your homework for today. It's going to look like this. And I need to find real quick the actual simulation. So let me do that. You will have this linked on Schoology. So you're going to go there. You'll click on the link. The link will bring you to something that looks like this. And you click on Atom. And it'll look like this. Here's how it works. Open up these two boxes. And you are going to basically follow the directions over here. And you're going to start off by creating a helium atom, which is 2 protons, 2 neutrons, and 2 electrons. So I'm going to click and drag the 2 protons in, 1 and 2. Then I'm going to click and drag the 2 neutrons in, 1 and 2. And then these 2 electrons, you're going to see they're going to come right there. And now it says it's neutral. You can see that they're doing the positives and negatives just like we are. You can see the mass number that we created, and you can see how it changes as I go and I take away and add things to this. You can see how the charge changes as I add more electrons. The electrons are negative, so when I added an extra electron there, see, look what I do. Now it has a -1 charge because there's an extra negative electron. It's called a negative ion, okay? If I add the proton, like I taught you the other day, it's going to change what element I'm looking at. So I add it in, and it changes it. Now it's lithium, okay? So just things for you to play around with as you go through and you try to answer these. Now, a few quick notes before I let you go. Here, I want you to sketch what you made. When I say sketch what you made, I mean it should look like this with the circles and the rings and all that. And then I also, down over here, a common mistake is that in this box, people will sometimes just sketch this. I do not want this in this box. When I talk about sketching something, I want a sketch that looks like this. I want you to basically draw the Bohr diagram of it like we've been learning about with the circles and the rings. That's what I want over here, okay? So with that, you can go ahead and get started. Good luck.